Welcome back, everybody. Hope your distance learning is going well for you. Remember, you can always send me an email and we can schedule a conference call or just communicate through email if you have any questions as we go through this chapter. Today, we're going to talk about our basic exponential growth model. We looked at this beginning in chapter 4. Our equation was y equals b times g to the x power. So what makes it an exponential equation is that your variable x is an exponent. In this equation, our b value is our beginning amount. The starting amount, that would be our y-intercept if we were graphing it. In this example, g here is called the growth factor. That is the base that's being raised to the power, and that describes how fast it's going to grow. And our x is our variable. It's representing time in this case, the number of time periods that we're allowing our beginning amount to grow. This is basically the model that's going to be used for all other exponential formulas. So if we change this a little bit to pertain more to our investing money type questions, it would look like this. So A would represent our final amount. P in this case is called the principal. It is still the beginning amount, but when we talk about money, the principal is used, we use the term principal to represent that starting amount. Our R value here is typically a rate of growth. In this case, we call it a rate of return based on the type of investment we have. And our X again represents the number of time periods. So we're just going to look at a couple examples of what happens as we change our rate of return and as we change the amount of time we have. So in our first example, it says if a person has $5,500 and invests it in a balanced fund with a 50-50 split, how much would the person have after the following number of years? So we're going to look at what happens as we increase the time from 5 years all the way up to 47 years. Our starting amount here would be this $5,500. Okay, that would be our principal. And in this case, our balance fund for this year, for 2020, the balance fund rate is 8.2%. Now, anytime we are plugging that percent in, that rate of return in our equation, we have to convert it from a decimal to, from a percent to a decimal. So we're going to put this in our equation as 0.082. Anytime you change from a percent to a decimal, you're just moving your decimal back 2 places. So we're going to set up our equation here. We have 5,500 as our principal, and we said our equation was amount equals our principal times 1 plus our rate of return to the x power, and x was our time. So we have 5,500 as our principal. Our interest rate, or our rate of return, was 8.2%. Again, we converted that into 0.082. The 1 here that you see in this equation stands for the original 100% of your principal. If you don't have that in there, if you just put 0.082, your money is going to decay instead of growing. So we do need that original 100%, and now we're making it grow by an extra 8.2%. So what I'd like you to do as you're watching this video is to pause it as we go through the equations and take a few minutes to actually put these in your calculator and make sure that you're getting the same answer we have. All right, so for our first one here, the 5,500 times 1.082 to the 5th power, we should have a value of $8,156.41. If you're looking at your calculator, the decimal here would be 0.4089. And we always want to round. You're going to be entering some things in Schoology quizzes for this chapter, and we want to make sure we're rounding correctly. So if we are rounding money, we typically cut it off after the pennies, and anything higher than 5 or higher would make this round up. That's where we're getting the 1 here. All right, so now what I'd like you to do is hit second and enter, that should recall your original equation, and then all you have to do is change the time here into our next ones here, the 10, the 20, the 40, and the 47. So go ahead and pause the video for a minute and get a total for each of these new equations. So once again, we are just changing our times. So how much are we going to have after 10 years, 5 years, 10 years, 20 years, 40 years, and 47 years? Okay, hopefully you've had a chance to try those on your calculator. Remember, if you hit second enter, you can recall your previous calculation and just make the changes for the time. So let's look at what happens in each of these cases. You'll notice that after 5 years, we had only gotten our $5,500 up to a little over $8,000. After 10 years, we were just over $12,000. After 20 years, we were at $26,600. After 40 years, we had made it up to $128,600. And after 47 years, we were at $223,379.82. So what I'd like you to notice here is as the time increases from 5 to 10 to 20, etc., our value of the total value of that initial investment of $5,500 ends up being $223,379.82. So it's grown quite a bit in those 47 years. Now we chose 47 because if you are 18 right now, 47 years from now, you will be 65. And that's a typical retirement age. So we're looking at what happens if you had put $5,500 in right now when you're graduating from high school. If you had invested $5,500 in an account that was paying 8.2% average return each year, and you just left that money in there for 47 years, you would have $223,000 instead of your $5,500. So it's grown quite a bit. So this is a case where we're looking at compounding interest and the advantage of time. Compounding means your interest gains interest. So as you leave that money in there from year to year, they keep adding your interest into your initial balance of $5,500, and so your new principal increases. And we're looking at what is the advantage of time. In this case, we went from 5 years up to 47 years, and because we had so much time, we were able to increase our dollar amount quite a bit. Now, what would happen if we had left that money in there just one more year? So let's just look at 47 years, and now we're changing it to 48 years. Notice that the change here is not the same each year. From 5 years to 10 years, we went up $4,000. But from 10 years to 20 years, we've gained more than doubling that, more than just an $8,000 increase. And that's the compounding idea. So even just 1 year makes a huge difference in terms of your final amount. So the idea here is go ahead and get things invested early so that it has time to grow by the time you want to retire. All right, our second example that we're going to look at uses a growth fund. And yesterday when you were talking with Mr. Janan, you looked at a growth fund with a 80-20 split, and that rate for this year is 9.4%. So in this case, we are still looking at $5,500. Our interest rate, though, has changed from 8.2% to 9.4%. And we're going to look at the same years from 5 all the way up to 47. So let's go ahead and set up this first one. We have initial principal balance of $5,500. That's the amount we're investing. We are gaining an extra 9.4% on our money. So we have our original 100%. Again, that is the one that you see in this equation. But now we're adding an extra 9.4%. And we're going to look at what happens over time. So pause the video, go ahead and calculate 5 years, 10 years, 20 years, 40 years, and 47 years. And once you have those totals written down, go ahead and turn the video back on and check your answers. All right, so you should have had $8,618.85 for 5 years, 10 years, $13,506.28, 20 years, $33,167.22, 40 years, $200,011.78, and 47 years, $375,125.70. So what we want you to see in this example, we've got the same principle of 5,500 that we had in our first examples. Our times were the same. We're still using the 5, 10, 20, 40, 47. But you'll notice that your total amount here was $223,000. And here we have $375,000. Quite a difference. And the idea here is the extra advantage of return. We're changing from 8.2% to 9.4%. Over 47 years, that makes a huge difference. So instead of having $223,000 when you want to retire, you'd have $375,000. Now that's simply putting $5,500 in one time, 18 years. When you're 18 years old, by the time you're 65, you'd have $375,000. If you continue to invest, obviously your total amount would increase. And we're going to look later in the chapter on that scenario. So once again, let's just look at what happens if we just add one extra year to that. So instead of 47 years, now we're looking at 48 years. And it jumped from $375,000 in that 1 year to $410,000. So the idea here is make sure that you start investing as early as possible, even though retirement might seem like a long way away. It makes a huge difference in how much money you have at the end. Send me an email if you have any questions. Hope you have a great day.